Alright, now we're going to talk about factoring quadratics that are difference of squares. And you're going to know what I mean by difference as you're going to look at the final answer for this example. So when we're working with difference of square, first you always check for the first term. The first term has to be positive, always. Now, doesn't guarantee you that you're working with difference of square, because based on the previous section of 9.4, we work with perfect squares, and then all the examples were positive. So when we're working with perfect squares and difference of square, we must check that the first term is positive. So in this case, we're going to check the first term is indeed positive. So, and again, so to review, when you're working factoring of perfect squares, difference square, we must check for positive for the first term. Now, in our first example, we have x squared minus 9. So, we have the first term and the last term. The first term is positive, so we good. We're going to move on to the next part. Is the first term and the last term perfect square? X squared, yes, that's a perfect square. 9, that's a perfect square. So, if the first term is positive, now, I forgot to mention that when we're working with difference of square, the middle operation is subtraction. So, difference, if we tie it into operation, it means minus or subtraction. So, this process, as we're going to, only works for when it's two perfect squares, which established earlier, and it's a minus in the middle. So if this is a positive perfect square, if that's a perfect square, and it's a minus, then we can work with this method. So if it is perfect square, this first one is positive, the middle operation is minus. So what we're going to do is we're going to do the square root of the first term and the square root of the third term. So when we do the square root of x squared, it will simply be x. The square root of 9 will be 3. So once we have that, right now the answer will be easy. We're going to have two set of parentheses. One will be plus, one will be minus. The first term will be x in both of them. The second one will be 3 in both of them. And that will be our final answer. So, our two factors for x squared minus 9 is x plus 3 times x minus 3. So, just to review, first you gotta make sure the first term is positive. Next, you gotta make sure that it's both the first term and the last term are perfect squares, which we did right there. And in the middle operation is a subtraction. So once those three conditions met, first term is positive, both terms are perfect squares, middle operation is minus, then we can do the square roots of both terms, which were x and 3. And then what I did is I wrote two set of parentheses, one plus, one minus. My first term is here, which is x. My last term, which is 3. So they both have x, they both have 3. The only thing different is one has plus and one has minus. Now, this will always work for perfect square, and the reason is, if I were to FOIL this, so x times x, x squared, x times minus 3 will be minus 3x, and then 3 times x will be plus 3x, and then positive 3 times negative 3 will be minus 9. So these two terms, combine them, they will cancel out, and you're left with x squared minus 9, which matched with the example. So you will see a pattern when you're looking at the final answer. First term is the same, last term is the same, just different operation. Alright, in our second example, we have x squared minus 100. So first, we check if the first term is positive, which it is. Middle term, it says subtraction, so that's good. And then the last part is the first term and the last term perfect square. X squared, yes, perfect square. 100, yes, perfect square. So that means we can do the square root of the first term, the square root of the last term. Now to make sure, again, it has to be a minus in the middle. If it was a plus, this will not work. This process, this method will not work for if it's plus. So the square root of x squared is x. The square root of 100 will be 10. So once we get those out, all we're going to do is just write our answer. So here's our two set of parentheses. The first one is x, and then the last one, the last term, is 10. And then remember, one parenthesis, one answer will have one plus. The other parenthesis, the other answer will have a minus. So x plus 10 times x minus 10. That will be our final answer. So to review what was mentioned before, it only works with subtraction. So if you see a plus, even though positive perfect square, even though it's plus, this method, this process will not work for it. You won't get the right answer, you won't get the same answer. So again, it only works if it's a minus in between the two perfect squares. In this third example, we have 36m squared minus 25p squared. Now what's different, aside from using different variables, is that we actually have a number in front of the first term, which is still okay. All the other examples that we worked with, even though they did not have a number, they had an invisible 1 in front of the variable. Invisible 1 is also a perfect square. Now, same process, you can still work with it. First, check if the first term is positive, which it is. Next, we're going to see if it's a perfect square. 36, 25, they are perfect squares. M squared, P squared, also perfect square. We're good to go. Next, I see that it's a minus, so we're also good to go. So after we check for that, square root the first term, square root the last term. So the square root of 36m squared will be 6m. The square root of 25p squared will be 5p. So I'm going to put parentheses. The first term will be 6m in both of them. The last one, 5p, will be the last part of each answer. Then one has plus, the other has minus. So 6m plus 5p, and then 6m minus 5p. That will be our final answer. So to review, this example had a number in front of m squared, a number in front of the first term. It's still able to work as long as it's positive perfect square. And when it is, when you check for both perfect squares, minus, and then the first one is positive, you can still do the square root, 6m, 5p, and then just plug it into your answer. 6m plus 5p, 6m minus 5p. That's it. In our fourth example, we have 100a squared minus 49b squared. So first, let's check. The first term is positive. We're good to go. Both numbers, 100 and 49, are both perfect squares. Good to go. A squared, b squared, also perfect square. We're definitely good to go. Next, and lastly, the middle operation, it's subtraction, so we're for sure good to go. So square root the first term, square root the last term. The square root of 100a squared will be 10a. The square root of 49b squared will be 7b. So we're going to put a set of parentheses. So our first term, 10a, will be 10a here, and then 10a here. And then the last term, 7b, 7b here, and then 7b also here. Lastly, we're going to put plus here and then minus. Now, what I forgot to mention is that the order does not matter. So if you happen to put subtraction or minus first and then plus in the other one, that's okay, as long as they're two different operations. So again, order does not matter. So in my example, I have been putting plus first and then minus second. But if you put minus first and then you put plus second, that's okay. But if you put the same operation, that's wrong. So again, if you put the same operation, if you put two minuses or you put two pluses, then it's wrong. It has to be one answer has to have minus, one answer has to have plus. Order does not matter. So our final answer here is 10a plus 7b times 10a minus 7b. Now, if you had wrote 10a minus 7b and then 10a plus 7b, then that is still correct. That will be acceptable. That will also be a final answer, as long as you follow the order you set for your setup, and they both have different operation. 1 minus 1 plus, 1 plus 1 minus.